2B frequency distributions in their graphs. Now we're going to look at the graphs of qualitative data. We already did the frequency distribution from a set of ages. So here we have our classes with our class boundaries. We have our frequencies, our relative frequencies, our cumulative frequencies, and our midpoints. So now we're going to use all of these pieces to create our graphs. Now the first graph that we're going to do is a frequency histogram. Now a frequency histogram is essentially just a bar graph, but for quantitative data. Now a couple things are going to change from how we did a bar graph for qualitative data. First of all, with frequency histograms, the bars touch. So there's not that space between them because the number line is consistent and continuous. So the bars are going to touch. Also, instead of using categories along the x-axis, we're going to deal with either class boundaries or midpoints, depending on how we do it. So I'm going to start with using class boundaries because that's personally my preferred method. Doesn't mean it's the best method, it doesn't mean it's the only right method. It just means that's the method I prefer to use because I feel that it tells me more when I look at a graph. I can understand it faster that way. So let's create a frequency histogram for this data. So if we're going to do so, first of all, we're going to put our x and y axis there. Now we're dealing with a frequency, so I can label the y-axis as frequency. And those frequencies go from 2 to 3. Not a lot of excitement in this. I kind of wish the data had worked out a little differently. That's what happens when you randomly select data. Okay, so it's going to have to go through 3, so I'm just going to number by ones. 1, 2, 3. So there we go. Y-axis is taken care of. The x-axis, as I said, the method I'm going to use is I'm going to use the class boundaries. So I see 18.5, 18.5, 29.5, 40.5, 51.5, 62.5. So there we go, I have my class boundaries listed. And notice too that the class boundaries moved by the class width also. The class width on this was 11, and the class boundaries are moving by 11, which makes sense. So now what I'm going to do is, I realize that this class really starts at that class boundary and ends at that class boundary. So when I create my bar for my histogram, I'm going to start at that first class boundary, go up to the frequency, go over and go down at the next class boundary. So at 18.5, I'll go up to 3. Then I'm going to go over to 29.5 and I'm going to come back down. So I come down to 29.5. My next class starts at 29.5. It also has a frequency of 3. So it's going to start there and go over to 40.5. Next one has a frequency of 3. It's going to go over and go down to 51.5. And then the final one has a frequency of 2. So it's going to start at 2, go over, and go down. And I have created probably one of the most boring frequency histograms that I have ever created in my life. Okay, so you can see that the first class comes from 18.5 to 29.5. The second class goes from 29.5 to 40.5, third class from 40.5 to 51.5, and then the last class from 51.5 to 62.5. So that is a frequency histogram. The bars touch, they go from boundary to boundary, and we make sure we label the frequency, and we number our y-axis. So that's a frequency histogram using class boundaries. The reason I like class boundaries is because it's very easy for me to determine what data values fall into each of these bars of the histogram. If I want to know which class, by looking at this graph, I would find the number 31. It's obviously in the second class because 31 is between 29.5 and 40.5. If I want to know where 40 fits in this, 40 is less than 40.5, so it's in the second class. So it's very easy for me to tell what data is in that class. That's why I like to use this. Now that's one way you can create a frequency histogram. The other option is that we can use the midpoints, kind of like we did category names for bar graphs, instead of using the class boundaries. So I do the same thing, label my y-axis, it's going to be frequency, and I'm going to have to go up to 3, so I have 1, 2, 3. I label my x-axis, but now instead of using the class boundaries, I'm going to use the midpoints. So I've got a midpoint of 24, 35, 46, 57. So I have my midpoints. So now we are going to center our bars of our histogram over these midpoints, and the bars are going to touch each other just like they did in our other frequency histogram. So I go to the first class and I've got 3, so I'm going to center that nicely over the 24, and then my next class has 3, I'm going to go from there and center it nicely over the 35, next class has 3, center it nicely over 46, and then my final class has 2, so center it nicely over 57, and I now have my frequency histogram. Notice it doesn't really look any different, it's just the numbering on the x-axis, that's the only thing that changed. Now with that, I will point out you want to be very careful. If you are using class boundaries, make sure those class boundaries are right under those vertical lines, so that you draw your lines right over those class boundaries. If you're using the midpoints, make sure you center your bars over that so they're not at the line. Otherwise, it gets very confusing to people who are trying to read your graph. So that's a frequency histogram. The next thing we're going to do is a relative frequency histogram. And that should seem kind of familiar to you, right? We did a frequency bar graph, and then we did a relative frequency bar graph. So same thing, and remember the only real difference between a frequency bar graph and a relative frequency bar graph was that the y-axis turned into the relative frequency. Everything else came out the same. So that's really what's going to happen here with a relative frequency histogram. We're going to start out, we're going to call it relative frequency. We know our relative frequencies go from 0.18 to 0.27, so I'm just going to go 0.1, 0.2, 0.3. I'm going to use the class boundaries. We can use, just like with the frequency histogram, we can use either the class boundaries or the midpoints for a relative frequency histogram. I'm going to choose to use the class boundaries. So 18.5, 29.5, 40.5, 51.5, and 62.5. So I've got those, and now I'm just going to do the same thing I did before, but looking at the relative frequencies. I'm going to start at the first boundary. My relative frequency is 0.27, so I'm going to go up to 0.27, go across, and go down at the next boundary. My next class, 0.27, across, and down to the next boundary. My next one, 0.27, across, and down to the next boundary. And then the next one, 0.18, so find where that is, across, and down to that boundary. And that is a relative frequency histogram. Again, that could be done with the midpoints instead of the class boundaries. If I did that, and I'm just going to use the magic of a whiteboard here. If I did that, then this would be centered over 24, 35, 46, and 57. So that's what it would look like if we were dealing with a relative frequency histogram using midpoints. So there we go. So now we've dealt with our histograms. We do a frequency histogram or a relative frequency histogram. Remember, for histograms, you can choose to use the class boundaries or the midpoints. That is your choice. So let's get that out of the way. And now we're going to go to a frequency polygon. So a frequency polygon. If you remember your geometry, a polygon is a closed multi-sided figure constructed from line segments. Closed multi-sided figure, you could even put in two-dimensional. A closed two-dimensional multi-sided figure composed of line segments. Meaning that right there is a polygon. It happens to have 4 sides, it's closed, meaning that you can't get into it without crossing over the line. It has multiple sides, and those sides are all line segments. Not a polygon. That's not a line segment, that is a curve. Not a polygon. It's consisting of purely line segments, and it's multi-sided, but it's not closed. I can go into it without having to cross one of those lines. So when we graph a frequency polygon, we can expect that we're going to create a closed two-dimensional multi-sided figure consisting of line segments. So you can kind of look at a polygon, a frequency polygon, as being a line graph. We're going to have points and connect them with lines. So the way we start this, and again, we're going to have x and y axis. It's dealing with a frequency. So we're going to call this frequency, and we know that that we go up to 3. So again, 1, 2, 3, consistent indices. And then for a frequency polygon, you must use the midpoints. So a frequency polygon, you must use the midpoints. So I'm going to put the midpoints on the x-axis, but I'm going to give myself a little space before I do that. So I'm going to go 24, 35, 46, 57. So now I have my midpoints on my x-axis. Then I'm just going to go to each class and find the frequency and put a dot above its midpoint. So the first class has a frequency of 3. I'm going to put that above the midpoint, 24. The second class, a frequency of 3 above that midpoint of 35. The third class has frequency of 3 above that 46. The fourth class has a frequency of 2 above that 57. And then, just like we did in grade school, we're going to connect the dots. Now I have a multi-sided figure consisting purely of line segments, but it is not closed. Notice it is open here. So how do we fix that? Well, there's a mathematical method that we use to fix this. And what we do is we look at our original frequency distribution and say, well, wait a second. What if we went a class before our first class? Well, if we go a class before our first class, it's going to have a midpoint too. Remember, this had a class width of 11. 24 plus 11 is 35. So if I subtract 11 from 24, I get 13. So 13 would be the midpoint of the class before the data began. So I'm going to put that on my graph, 13, and I'm just putting it in red here. You don't have to do it in a different color. I'm putting it in red kind of denotes to me that this came from elsewhere. I went back to a class before the data began. Now, if that's before the data began, then what's the frequency of data in that class? Well, obviously 0, because it's before the data. No data happened there. So we're going to have a frequency of 0. Notice that now I can connect this first class frequency down to the x-axis. Now I can do the same thing on the other end, and I can go one class beyond all the data. So 57 plus 11 is 68. So I go over here and add 68. And if it's beyond all the data, the frequency in that class is also 0. So now I can connect this end of the graph down to the x-axis. And notice that now, when you include the x-axis as part of it, we have a closed two-dimensional, multi-sided figure consisting purely of line segments. So this is a frequency polygon. So how did we get that again? Well, we started out, first of all, we labeled our y-axis as being frequency and number and consistent indices to make sure we could fit our frequencies. Then we took our midpoints and put them on the x-axis. Always has to be the midpoints. We then plotted our frequencies versus our midpoints, connected the dots, and then said, okay, well now we need to get it down to the x-axis, so we went back one class, subtracted our class width from the midpoint, and got the midpoint of the class before it, and we knew the frequency there had to be 0, and then we went one class beyond it, and we knew the frequencies there had to be 0, and connected them down to the x-axis, and we came out with our frequency polygon. Frequency polygons always have to use the midpoint, and we are not going to deal with relative frequency polygons. Technically, you could do it. You could put relative frequencies and do the same thing, but we're not going to deal with that. We're going to deal only with frequency polygons. So that's another type of graph that we can do for quantitative data. We're going to do one more here. Get rid of this polygon. And we're going to do a cumulative frequency plot, otherwise known as an OGIVE. That's right, it's an OGIVE. It's not an OGIVE, it's not an OGIVE, it's an OGIVE. And it has to be done with the bobblehead. It doesn't work to just say it's an OGIVE. No, it's an OGIVE. Okay? So an OGIVE is a cumulative frequency plot, which means we're going to be plotting these cumulative frequencies. It also means that if we think about what cumulative means, it means to accumulate, to add to, that just like our cumulative frequencies should always continue to go up and never go down again, our cumulative frequency plot is always going to go up and never go down again. When you're dealing with cumulative frequencies, they're either going to remain the same because you just added nothing to them, or they're going to go up. They're never going to go down. Same thing with our cumulative frequency plot. It may go up and then it may plateau and then it may go up some more, but it's never going to go back down. So if we're doing a cumulative frequency plot, we start out the same way, put our x and y axis here. Our y-axis is going to be cumulative frequency, so we label that. And our cumulative frequencies go up to 11, so we're going to make sure that we have enough space here to do that. So I'm going to go 2, 4, 6, 8, 10, 12. Okay, consistent indices. And then for a cumulative frequency plot or an ogive, we always use the class boundaries. We always use the class boundaries. And the reason we use the class boundaries is because that's where we know how many data points we've come across. If I go into the middle of my class to my midpoint at 24, I don't know how many data points I've come across. I might have come across all 3 of these already, or I might not have come across any of them, or some mixture in between. So we're going to use our class boundaries because I know at 18.5, I haven't come across any data yet. I haven't even got into the class yet. I know at 29.5, I've got all my data from that class. And again, 29.5, I'm still sitting at all that data from class, and then at 40.5, now I've accumulated both of those classes. So we're going to use our class boundaries. So it starts at 18.5, 29.5, 40.5, 51.5, 62.5. So I've got my class boundaries. And this is going to be another line graph. So at 18.5, as I already said, we know that that's going to be a cumulative frequency of 0 because we haven't come across any of the data points yet. So a cumulative frequency plot is always going to start right on the x-axis. It's going to start at 0, and then it's going to increase from there. So when I get done with my first class, I'm at 29.5, and I have 3 data points. So I'm going to put a point at 3. When I get done with the next class, I've now got up to 6 data points. When I get done with my next class, I'm going to be up to 9 data points. And when I get done with my final class, I'm up to 11 data points. And then I'm going to connect those dots. And we see that it is constantly increasing. If I had a class that had a frequency of 0, and that can happen, I could end up where somewhere along the way there just weren't any data values in that one class, that one little range. If that's the case, what would happen is it would just plateau. It would stay the same for that class, but it's not going to go down. It might just do a horizontal line, but it's never going to go down. And we don't connect that down. There's no valid reason to do so. So this is called an ogive, or a cumulative frequency plot. And what did we do? We put our class boundaries on the x-axis. We called it a cumulative frequency plot over here, and we numbered our y-axis to be able to fit all the cumulative frequencies and had consistent indices. Then we just plotted the number of data points or the cumulative frequency at each boundary, always starting at 0, because at the lower class boundary of the first class, we haven't come across any data points, and then just going by the cumulative frequencies, 3, 6, 9, 11. And that's our cumulative frequency plot. So not bad.